Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Mariam Nacheune from Volted Installations, and today we are going to understand what power factor is, what you can do to improve it, and why you should care, all under 3 minutes. Well, to understand power factor, we have to understand these terms: real power, reactive power, and apparent power. Real power is the power that the equipment that you have in your factory uses. The reactive power, it is the power that is used to produce a magnetic flux. So this is used by things like transformers, induction motors, relays, and the apparent power is the vectorial sum of the real power and the reactive power. Note that I've said it is the vectorial sum. It's not the algebraic sum, it's the vectorial sum. So what is power factor? Power factor, it is the cos of that angle between the total power and the true power. So it is the ratio of the real power to the apparent power. Taking us back to our beer analogy, you see, you can't have beer without foam. So it is impossible to have an equipment running without any reactive power. But the more reactive power you have, the less your power factor, and vice versa. So utility companies want you to have a power factor of 1, which is unity, because that means that you have zero wasted energy, which is the reactive power. It is ideally not possible, but it is the goal. So again, like I said, some of the causes of having a less power factor is having inductive loads, things that are going to give you that reactive energy. So things like transformers, induction motors, induction generators, and high intensity discharge lighting. These all cause your power factor to be low. The reactive power that is required by these loads increases the amount of apparent power in your distribution system. So why should you care about having a low power factor? The first thing is it lowers the utility costs. It reduces the real power demand billing, the KVA. Like I said in the previous video, KVAs are billed. And the second thing is you eliminate the penalty. Having a power factor less than 0.85, you incur a penalty with the utility companies. And the second thing as to why you should improve your power factor is when you increase the power factor, you increase your system capacity. So you increase the amount of KW, the real power you use in the system. And you also increase the efficiency and the voltage levels of the systems. Assalamu alaikum wa rahmatullahi wa barakatuh. So now that we've understood what power factor is, what causes it, and why we should care, let's talk about how we can improve it. Like I mentioned in the first video, sources of reactive power, these are the inductive loads, they decrease the power factor. So consumers of reactive power, they increase the power factor. So things like capacitors, synchronous generators, and synchronous motors, they increase the power factor. And adding capacitors to the system is a good way of increasing your power factor. It's the first thing that most engineers go to. And this is a simple formula that you can use to calculate the required capacitance, the capacitance you can add to the system to improve its power factor. The next thing we can do to improve our power factor is to minimize the operation of idling or lightly loaded motors. This will help us increase the overall system power factor. Another point would be to avoid the operation of equipment above its rated voltage. And the last point I'm going to talk about is replacing the standard motors with energy efficient motors. Again, like I said, these are sources of reactive power. So if you're replacing them with more efficient motors, you're effectively reducing the reactive power and hence increasing your power factor.